Good day, BTL Advanced students. For today's video, we will be learning all about graph coloring. At the end of the discussion, you are expected to define graph coloring, determine the chromatic number of a graph and find its corresponding coloring, and appreciate the importance of graph coloring in real-world applications. Class, when a map is colored, two regions with a common border are customarily assigned different colors, and we want to use the smallest number of colors instead of just assigning every region its own color. And that best specifies our topic for today, which is all about graph coloring. Okay? So we have here the four-color map theorem. It can be shown that any two-dimensional map can be painted using four colors in such a way that adjacent regions, meaning those which sharing a common boundary segment and not just a point, are different colors. To better understand the four-color map theorem, I have here the map of the contiguous United States. So as you can see, class, that regions which share boundaries don't have the same colors, right? So as you can see, there are four colors representing the map of the United States. So these are what we called the four-color map. Now, each map in a plane can be represented by a graph. So take note, class, that each map, it can be represented by a graph, or it can be presented, or it can be explained through a graph, wherein each region is represented by a vertex. Edges connect to vertices if the regions represented by these vertices have a common border, and two regions that touch at only one point are not considered adjacent. And this is what we called as the dual graph of the map. To better understand dual graph, I have here examples. As you can see, class, that this is a map. This is also a map, but we can represent it through a graph. So this would be the graph of the map. So take note that regions B, A, C, D, E, F, G are represented by vertices, or what we call the points, right? And if we see that the regions share common boundaries, like this B, A, and C, they share these boundaries. So it is represented by vertices. As you can see, class, B connects to A since they are adjacent, as well as the B to C and the C to A. So this would be the vertices. I hope I can make this clear, class. So let's take a look at the other graph, or the other map, which represented by a graph. So regions B, A, D, C, and E, they are five regions. So they are represented by five vertices. We have this B, A, C, D, and E. And take note that B, A, C share common boundaries. B, A, C. So they are connected by line segments, or what we call as the edges, right? Here, this connects to B, this connects to A, and this connects to C, as well as the C, A, and D. Regions C, A, and D, so they are connected by line segments or edges, C to A to D, and regions connect or share boundaries with regions E are the regions B, C, D. So in vertex E, this connects with vertex B, C, and D. Okay? I hope you get it, class. Now, let's proceed to graph coloring. So class, a coloring of a simple graph is the assignment of a color to each vertex of the graph so that no two adjacent vertices are assigned the same color. So let's take a look at this example. So as you can see, there are 5 vertices, A, B, C, D, and E. So vertices that share or connect with a line segment do not share the same color. So sa A, i-connect ni siya ni vertex B and vertex E. And they are not of the same color. Okay? That would negate or that would kanang di siya satisfy sa definition of the graph coloring. As well as the D. So si D, si E, and si vertex C, they are of not the same color since si D, gi-connect na siya, ga-connect sa E, sa vertex E, as well as the vertex C and the vertex A. So, si D, si A, o si E, di na siya pwede maparihag color. Am I right? But, in vertex A, vertices A and C, pareho sila color since they are not connected by a line segment or by an edge, as well as si B and D, they are not connected by an edge. So, they can be of the same color since their vertices are not adjacent. Okay? So, chromatic number of a graph. The chromatic number of a graph is the least number of colors needed for a coloring of the graph. So as I have said earlier class, in a graph, we cannot just assign each vertex by color or by different colors. In graph coloring, we need to color each vertex or color the graph with at least number of colors they can with no two adjacent vertices are of the same color. Okay? So let's take a look at this example. We have these bipartite graphs. When we say bipartite graphs class, these are sets of graph vertices decomposed into two disjoint sets, such that no two graph vertices within the same set are adjacent. So as you can see for this graph, these are composed of two disjoint sets since this first set and this is the second set. No two disjoint sets are adjacent, right? So the first color here, they are not adjacent, as well as the second set here, the second color, they are also not adjacent. So that is a bipartite graph. And if we have to determine its chromatic number, so they are at least two number of colors. So its chromatic number is 2. How about this 4-color theorem? So as you can see, this planar graph is 4-colorable. The red, the blue, the green, and the yellow. So as I have said, class, that two adjacent vertices connected by this line segment or edge must be of this different color. So, gasunod nga mga vertices, di na sila pwede magpareha og color nga gi-connect og line segment or gi-connect og edge. So this 4-color theorem is no greater than 4. The chromatic number is no greater than 4. Okay, let's have another example. What is the chromatic number for each of the following graphs? So let's take a look at this first graph. So if we are to assign colors, this would be the blue here, yellow, blue, and yellow. Blue, these vertices the blue colors could be of the same color since they are not adjacent. And the same with the yellow colors or the yellow vertices. They could be of the same color since they are not adjacent vertices. But this vertex, blue vertex, and this yellow vertex could not be of the same color since they are adjacent, as well as the yellow here and the blue here. They couldn't be of the same color since they are adjacent. So the chromatic number for this graph, since they are composed of two colors, is 2. Okay. How about this second graph? So if we are to assign colors, this would be the blue here is the same color with this vertex since they are not adjacent. The same with the yellow here and the yellow here. These vertices could be of the same color since they are not also adjacent. But this vertex here couldn't be blue or couldn't be yellow since it is connected or it is adjacent with the yellow vertex and it is also adjacent with the blue vertex. So we can assign it as another color. So the chromatic number for this graph would be, since there are 3 colors, it would be 3. Okay. So now let's apply the graph coloring. Determining the chromatic number of a graph and finding a corresponding coloring of the graph can solve a wide assortment of practical problems. One common application is in scheduling meetings or events. So scheduling meetings is best shown by this example. 8 different school clubs want to schedule meetings on the last day of the semester. Some club members, however, belong to more than one of these clubs, so clubs that share members cannot meet at the same time. How many different time slots are required so that all members can attend all meetings? Take note, class, that clubs that have a member in common are indicated with an X. So this would be the table. So member is both in a Sky Club and student government. So this is best represented by X. The same with the other X's. So for this example class, we can represent this given information by a graph. This one. So as I have presented you in the preceding lessons, I have already discussed how to construct a graph out from given information. So we put acronyms here. SC represents the Sky Club, CR for Community or Campus Republicans, CD for Campus Democrats, CO for Community Outreach, SN for Student Newspaper, HS for Honor Society, DC for Debate Club, and SG for Student Government. So if we will take back with the table, so there are many X's. Sky Club and Student Government share X. The same with Sky Club with Honor Society and Campus Director and Campus Republicans. So Sky Club is connected with the Student Government. So they are connected with an edge. The same with the Honor Society. So this connects with the Honor Society. And the Campus Democrats and the Campus Republicans. The Campus Democrats is CD, so it is connected with this vertex, as well as the Campus Republicans. So the same thing with the other vertices class or the other clubs. If we will take a look with this table, an X represents nga nag-connect sa mga vertices or nag-connect sa mga clubs. So, two clubs that are connected by an edge cannot meet simultaneously. So, di sila pwede mag-meet pareho since they are connected. The same with this one, the same with the CD. Okay? So, if we let a color correspond to a time slot, then we need to find coloring of the graph and uses the fewest possible number of colors. So by little experimentation using the trial and error method, we come up with this graph assigning with respective colors. So as you can see, there are three. The chromatic number of this graph is 3. There are 3 colors. And each color corresponds to one time slot. So the scheduling would be the first time slot, the club, Sky Club, Debate Club, and Student Newspaper could could schedule meeting. For the second time slot, it would be the student government and the community outreach. And for the third time slot, it would be honor society, campus Democrats, and campus Republicans. So take note, class, that those clubs with different colors, they are those clubs with the same colors, they are not adjacent, right? And so they could be kanang they don't have members of the same clubs. So si CR, si D, di sila pareho og mga members. The same with HS. The same with the Sky Club, the debate Club, and the Student Newspaper. They have members that distinct members. Dili sila pareha og mga miyembro. So they could schedule a meeting nga everyone could attend. Another example, we have 5 classes at an elementary school have arranged a tour at a zoo where the students get to feed the animals. So these are the corresponding classes with the animals they want to feed. So the question is, if the zoo allows animals to be fed only once a day by one class of students, can the tour be accomplished in 2 days? So let's assume that each class will visit the zoo only on one day. If not, how many days will be required? So as what we did earlier, class, this information can best be represented by a graph. So we use vertices to represent each class. Class 1, Class 2, Class 3, Class 4, and Class 5. And we connect two vertices with an edge. This one, if the corresponding classes want to feed the same animal. So let's take an example for Class 1 and Class 2. Yes, they both want to feed elephants, so they are connected. In Class 1 and 5, Class 1 and 5, they want to feed hippos. Okay, so they are also connected. With Class 1 and 4. Class 1 and 4, they want to feed giraffes. Okay. With Class 2 and 3, they want to feed monkeys. So they are connected by this edge. The same with Class 3 and 5, and also Class 4 and 5. They are connected since they want to feed the same animal. So, if we are to experiment using the trial and error method, if we are to assign colors for this graph, this would be it. So we assign colors to vertices 1 and 3. Since they are not connected, they could be of the same color. right? The same with 2 and 5. They are not connected, so they could be of the same color. But in 4, the only class it is not connected is 2, but it couldn't be blue or color blue since this is adjacent to 5, which is of color blue. So we assign it as another color. Since there are 3 colors for this graph, the chromatic number for this is 3. Therefore, 3 days are required at the zoo. So on the first day, classes 2 and 5 will visit the zoo, okay? So on the second day, classes 1 and 3 represented by yellow color or yellow vertices, they will together visit the zoo. And the class 4, represented by the green vertex, will also visit the zoo on the third day. Okay? I hope you have all understood our lesson for today, class. So if you have queries regarding this, you can chat me directly. So for your assessment class, I want you to draw 4 color map. Note that it must be colored, meaning for color map, we utilized 4 colors. Okay, it is worth 10 points. For number 2, draw a graph with a chromatic number of 3, meaning we will utilize 3 colors. And label each vertex with colors. Take note also, class, that 2 adjacent vertices shouldn't be of the same color. They should be different. Okay? Submit it in our Google Classroom. For your assignment, you are to research and study in advance modular arithmetic. So thank you for today, class, and happy learning.